Let's just go through the macros coding again in terms of optimizing a case. Right, so we're going to step through and debug each of these macros. So going through the new case first, right? So under the new case macro, we have 4 variables that's being defined, right? So the variables N, TPF, DSCR, and LTV. Next up, what it does is it goes to case num, which is this cell here. It picks up the value 1 and stores it away in variable N as a value 1. And then next up, it goes to the scenarios manager. And then it goes to the TPF hard-coded value, which is this cell here. And it picks up the 623300 in the TPF. Likewise, it goes to the DSCR, picks up the 138 and stores it away, right? And it goes to the sizing worksheet after that. So it jumps to the sizing worksheet. And the values that it just picked up, now it puts it into each of these blue cells, right? And that's the end of the subroutine. So once it does this and it populates these blue cells with a number, then the model flips from here to here, right? So that's the new case macro. So now it's in dynamic mode. So the model is floating. And it's trying to optimize these cells here, which are being used in a financial model, and then likewise in a debt schedule, we have the repayment schedule being based on this live formula, which is your DSCR divided your CFAS divided DSCR minus interest, right? So the model is dynamic at the moment. So next up, we need to optimize the case, because right now it's all the goal seek values are not 0, right? So again, going back to the subroutine, so let's move to the optimized case subroutine. So F8 to step in, right? So it looks at the TPF diff value and looks to goal seek it to 0, right? So it's goal seek that value to 0 now by back solving for the total project funding. Next up, it looks at the DSCR difference, which is this cell here, which is the repayment, the total repayment minus the debt amount. So again, it back solves that to 0. So once both are back solved, then that's the end of the subroutine, right? The last one, so that's the optimized case. The last one is the finalized case. So again, it defines a number of variables. And then it again picks up the case number and puts that into the variable N, stores it away. It goes to the sizing worksheet and it picks up each of these values, the TPF, the target DSCR, and so forth, and stores it away as a variable in the macro. And then it jumps to the scenarios manager. And then it basically pastes all those values into the right spots in the scenarios manager. So one here, one here. So the 1.42 has been updated. This has been updated as well. And then it jumps to the debt schedule. And it picks up the repayment schedule, the entire repayment schedule that was a live calculation, copies it, and it goes down to the library and pops it pastes it into the right row. And then after that, it goes back to the sizing worksheet and blanks out all those blue cells. And when it blanks out all the blue cells, the model flips from here back to here, which is the finalized case thing, right? And that's basically the how these macros work. Yeah. So likewise, if you do your thing and you decide that you don't want to store any of these values in the scenarios manager or store away the repayment schedule, you can just click on cancel case. And what cancel case does is it just blanks out all these cells without saving anything into the model. So it gets rid of everything. So in a nutshell, that's how the macro works. And so when you do this, you can then automate the key assumptions in the model to get the outputs you want, and then also to optimize the repayment schedule and get the repayment schedule you want in order to get a flat DSCR. The beauty of macros is that you can actually optimize multiple cases with it. So let's have a look at how this works. So let's say we're trying to optimize cases 1, 2, 3, right? So cases 1, 2, and 3. What this does is it's a macro where again you define two integers and max. What it does, it goes to the starting case, which is n min, picks up the value 1, stores that away, right? And then it goes to the other cell, which is n max, and the case 3, and stores that away as well. And what this macro does is it repeats new case, optimized case, and finalized case for scenarios 1, 2, 3. And yeah, so the way it does that is it uses a do while loop, right? So while the value n is less than 3, so the starting value for n is 1, right? So while it's less than 3, keep doing this loop, right? So then it would go to the scenarios manager, pick up the put the case number, update the case number. So right now it's 1. So we go to scenarios and put that as a 1. And then it would run new case, optimized case, finalized case. So the beauty of macros is you can actually put macros within macros. So this macro here basically invokes the new case, optimized case, finalized case macros from here. And then when it's done, it increases the n value by 1, and it does scenario 2. And then once it's done with scenario 2, it increases by 1 and does scenario 3. Once it done scenario 3, it would increase to 4, but 4 is greater than n max, which is a value of 3, and then it would break the loop and the thing right there. So let's just quickly see how that works, right? So going into the subroutine, so F8, so picking up the values, and then do while, so go into the do while loop. So 1 is less than or equal to 3, and then we go to the scenarios manager, make sure that's a 1, and then go to sizing, go new case, optimize case, finalize case, right? And then it's done with scenario 1. Okay. And then it goes back to n equals n plus 1. So now it increases to 2. And then 2 is still less than 3. So it goes back to scenarios manager, changes the scenarios manager scenarios number to a 2. And it does that. Again, optimize, finalize. Okay, so once it's done, it goes back to the scenarios manager and loop it to a 3. So now that's a 3, and it does it again. So this macro is powerful in that you were able to optimize multiple cases with one click of a button, right? Yeah, so that's kind of how this works, right? So if you click on, let's say if you want to do case 7 instead, so you press 7. All you gotta do is just click on optimize multiple cases. And then what happens is with a click of a button, you've optimized case 7. So let's go to case 3 again. Optimize, right? One thing you'll probably notice in here is that there's a code here that says application.screen updating equals false. Now, if you put apostrophe in front of that, right? What this code actually does is it stops the screen from updating as you run your macro, because it gets visually it becomes a bit, it can cause epilepsy if you do a lot of cases all at once. So I'll give you an example. So let's say we click on this. Yeah, so it's jumping around and copying and pasting and stuff like that. So it's so it does it in a flash. But if you look at it, then you probably get a headache from looking at all of that. So which is why we put in this coding here to stop the screen from updating as you optimize the macros. The other thing you'll notice in here is we have a calculate function in here. For these macros, I would not use the calculate function because then it would try and update all the data tables. So it really slow down all the optimization happening in the model. So you can make sure you don't put the calculate function in your macros, because that's going to update all the data tables on purpose, and it's gonna really slow you down. So once you kind of updated everything, if you really want to, at that point in time, want to update the data tables, you just press F9, and it calculates all the data tables and refreshes it. Alrighty. So that's kind of like macros. So again, this is, if you set this up properly, it can save you a lot of time, because oftentimes you'd be running a million cases and optimizing it with a single click of a button while you go get a cup of coffee or something. It really saves you time. Okay, so the next one, let's talk about the DSCR upside case. So usually in a utility scale solar project, for a single project, and specifically, especially for a project with construction risk, the lender typically has three requirements, right? They've got a gearing requirement. So they say that, hey, look, we're not going to fund more than 80% of your costs. There's also a DSCR requirement, and this is based on a P90 case, right? So again, just going back to P90, what P90 means is that it's a P90 output whereby only 10% of the time is the output below the P90 output. So it's quite a conservative assumption. So 90% of the time is greater, right? So it's a more conservative assumption. Now, usually the lenders will require a P90 of at least 1.2 DSCR and a P99 of, call it 1.05. But at 80% gearing, your P90 DSCR is actually significantly above 1.2, right? So if you go back to the financial model, now the P90 energy yield, it's roughly about 10% below the P50. So let's look at case one. So under case one, we have a 80% LTV over here, right? So it's 80% loan to value. So we're respecting that requirement of 80%. Now we're going to change the radiation yield, which is the energy yield here to the 1300, right? We're going to multiply by 90% to get, so 1300 is a P50 yield, which is the equity case. Now, if we give it a 10% haircut, now this becomes a P90 case. So under a P90 case, if you look at your DSCR, your DSCR is about 120, about 129, 1.29 times. So this is above the 1.2 that the lenders require from you, right? So which means that actually there's buffer in the DSCR result. So you're actually above the P90 DSCR of 1.2. Okay. But it is what it is. And sometimes you can play games on the gearing to get that gearing up and get the DSCR down to maximize your returns, right? Obviously, the higher the gearing, the better your returns. But typically, it's quite hard to do that with the banks. Now, in the upside refinancing, there's an upside refinancing potential here. So, for example, let's say you've completed construction on 500 megawatts of projects. First of all, you've reached critical mass, and you're also diversified, right? So, for example, the US dollar bond market, you need to have enough projects to raise a bond financing of roughly about 400 million US dollars. At least before the investment banks would be interested, which is roughly about 500 megawatts of operating portfolio, right? The attraction to the lender is the fact that an operating portfolio means that there's no more construction risk, right? So it's operating, and it has actual track record of revenue generation, operations, profitability, right? And then also multiple projects in a portfolio means that there's diversification as well. So if one project's not going very, very well, the overall portfolio is not affected, right? So if you have a diversified portfolio that's operating, that you can raise at least, call it 400 million US dollar, you can definitely tap the US dollar bond market, right? So you need to do a foreign exchange currency swap to swap it back into Taiwan dollars, because the projects we're looking at here is all in Taiwan dollar denominated revenue. But alternatively, we can also try and do a refinancing in the bank market as well. In which case that 80% gearing is no longer applicable, and they focus more on the DSCR. And a recent example of this is BlackRock. So if you guys Google the news, BlackRock acquired a local solar company called New Green Power, New Green Portfolio, New Green Power. After they acquired 100% of the shares, they did a refinancing with 7 banks, and this is exactly what they did. They refinanced it based on a P90 DSCR of 1.2, and got the gearing above 80%, and that bumped up their equity returns on the acquisition of NGP. So this is a potential upside that should also be considered as well when analyzing profitability of a project. So let's have a look in the financial model how this is done. So in the scenarios, this is actually scenario 3, right? So under scenario 3, first of all, we need to set the irradiation to P90. Right, so multiply by 90%. Okay, so that's the first thing. So once it's set to P90, now I've actually built it into the financial model, but you know how before we were doing a sizing based on targeting a DSCR such that the repayment is equal to the debt raised? In this scenario, what we're going to do is we're going to fix the DSCR at 1.2 times, right? So in scenario 3, the 1.2 times DSCR is fixed. What we're going to do now instead is to backsolve for the gearing, or the LTV. So increasing or decreasing the debt amount such that the debt amount based on a 1.2 times DSCR under a P90 case gets us to a goal seek of 0 for the debt sizing, right? So that's the way it's going to work. Let's go to the sizing worksheet again. So click on new case. Right, so we're in scenario 3. So it's picking up all the numbers from scenario 3 and exporting it here, right? Now, I've got a switch in here. So this, yeah, actually it's in the coding in the macro. So in the coding in the macro, I've got an LTV switch in here, right? So if you go here, okay, so I've got a switch in here, right? So there's a switch in here to see in when we optimize the DSCR, do we want to adjust the DSCR to ensure that the debt is repaid, or do we want to adjust the gearing, the 90% LTV, such that the debt is fully repaid? So this switch allows you to backsolve for the LTV assumption, right? The loan to value assumption, to get this to 0 rather than backsolving for the 1.2. So that's exactly what we're doing. So when we optimize case, right? So you see now that the LTV is goal seeked to 86%. And what you see is that our DSCR is exactly 1.2 times. So under the scenario where we're squeezing as much out of the debt financing as possible at exactly 1.2 times DSCR in order to maximize our leverage and our returns. And instead of getting an 80% LTV, we're getting 85.7, right? So once we've done that, then we can finalize the case, store everything away, including the repayment schedule for an 86% LTV loan financing. And then we can switch the, because we're running an equity case, once we've set the debt case, right, we can go back to the, energy yield and take away the 10% haircut and set it back to a P50, which is the equity case. So we size the debt amount and the repayment based on P90, which is a 10% haircut, but then we set it back to the P50, which is the equity case, to work out our equity returns. So once we do that, then you can see our returns. It's at 12.4%. Yeah. So in a nutshell, that's the P90 case in the financial model, how we manipulate that. So again, like the other cases, when we're not maximizing debt, we're trying to get as high a DSCR as possible. But in the P90 case, what we're trying to do is maximize the amount of leverage we can get to 1.2 DSCR. Whereas the other cases, we're capped out at 80% LTV. Yeah, so that's the financial engineering game we're playing in this scenario. Okay, that's the P90 case. Let's talk about debt covenants and cash lockup really quickly. I didn't actually model this into the financial model, but let's go to the LBO model. So this is actually pretty straightforward. This is a different file. It's called the LBO model. So at the bottom here, I've actually modeled out the DSCR, so it's 1.3 times over here in this particular model, right? And we have a lockup DSCR of 1.15. Typically for solar, if the base case DSCR is set at 1.2, it means that the lockup is usually 1.1, right? Yeah. So if it's at 1.2 times, then the what's called a lockup DSCR is usually 1.1. So it's usually 0.1 below. What this lockup DSCR basically means, if the DSCR is below 1.1x, no dividends can be paid. So it's a lockup. The cash is locked up. Okay, and the cash is locked up. That's why it's called a lockup DSCR. Now, sometimes it depends on how you negotiate with lenders, but let's say if the lockup DSCR is below 1.1 times 3 consecutive times, right? Because you measure this DSCR every time you make a repayment. Then the locked up cash is used to prepay debt. So if your project is in trouble and your debt service cover ratio is below the 1.1 times, the lender protects themselves by making you take this cash that's been locked up and pay down their loan. So it reduces their risk. So that's really the two elements of it. So one is that if it's below, you can't pay a dividend, cash is locked up, but if you're below consecutive times, then you got to use that to repay your debt. So that's what this, in this model here, this is what this does, right? So for example, in this model, we're assuming that if we get locked up 2 consecutive times, we have to prepay debt, right? So for example, so let's say if we go 1, 0, 1, 1, right? Let's just force the fail. So we failed the first lockup test, which means that if you look at our dividend payment in this, so the dividends paid in this period is 0 because we're not allowed to pay a dividend, and the cash is locked up. So the $10.3 million is locked up in the company, right? So that's the first year. Now in the following period, let's say for example that you didn't fail the lockup test. It's a no, you didn't fail it. So in this period, you're allowed to pay out the dividend, right? Including the locked up cash. So in this period, we're paying a dividend of $11.5 million, right? Which basically empties out all of the cash that's available in the company. Yeah, and then in terms of the following periods, let's say if you fail the lockup twice in the subsequent periods, which is these 2 periods here, then you have to sweep to debt, right? So there's a repayment in this period because you failed the lockup test twice, and the $38.5 million that's been locked up is used towards paying down your debt financing, which is over here. So there's a debt financing whereby you're paying scheduled repayments, but then you have an accelerated repayment because you fail your lockup test twice, which is a sweep to debt, a cash sweep mechanism. So I didn't model this into the main model, but you get a rough idea as to how this would work in practice. So that's the cash lockup, cash sweep mechanism. Okay, so I think that's pretty much all the things. Now let's quickly run through. I think we still have more time. Let's just. There's only really 2 elements left. It's the another 2 models that I want to quickly show. First of all, it's the. Let's take a look at the Greenfield model. So this was a model that I wrote back in 2006. It was a project in Saudi Arabia. It was a tendering process where we were bidding for the rights to build and operate and own a oil-fired power plant, which had a water desalination plant attached to it. So a portion of the electricity was basically diverted to the water desalination plant to produce fresh water for the country, and the payments made were from the government. And the way the revenue model was set up was that it was so the model was basically set up in the payments from the government was set up in 2 payments. One was called a capacity charge, which is like an availability based lease style payment, and then there was another usage volume charge, right? And the way it works is that the more electricity you produce and the more water you produce, the more of this payment you get, this usage payment, because you're incurring more fuel costs as well as more variable operating costs. So this is a strict cost pass-through mechanism to help you recover that additional cost. So the more you produce, if you're not producing any power, any electricity, any water under the instruction of the Saudi government, then you don't incur any of these costs, you get 0 payment. Now the capacity charge, which is basically a payment that's a lease style payment, so it's a fixed payment every month, and it's based on availability. So if your power plant isn't working, there's outages, then you get a deduction to this payment. But this payment is meant to cover for your fixed O&M, your debt servicing, as well as your equity returns. And this is really your EBITDA profit over here. So the model basically is a tariff optimization model where basically I'm trying to get the lowest tariff, because the lower your tariff versus the other bidders, obviously the higher chance of you winning, right? And again, it's the same principle where it's trying to work out what is the capacity charge that I can, the minimum capacity charge that I can pay such that I can fully repay my debt, as well as meet my equity returns, right? So that's kind of how the model works. So let's actually run through some of the features of this model, right? So first thing you notice is when you open up this model is that there is a, wait one sec, let me just close this down. Right. So the first thing you notice is that you can actually access the model. There's a disclaimer page that basically has a lot of legal disclaimers in here that you can't rely on blah, blah, blah. So you have to click on I agree before you can actually get access to the other worksheets in the model. And so, yeah, if you look at the macro, the coding, it's all explained here. So there's a disclaimer subroutine, which is invoked once you open the file, and it basically hides all of the worksheets. And the only worksheet that is visible is the notice worksheet, which is this one here. And then there's this macro button for I accept is linked to this disclaimer accept macro, which basically opens up all the other worksheets once you click on the button. So that's kind of how that works. Yeah, so let's go back. Yeah, let's have a look. Some of the other features in this model. Okay, the index worksheet. Okay, this one's a good one. So in the index worksheet, you see here that there's actually a bunch of hyperlinks, right? So for example, if you click on the profit and loss link here, it takes you to the P&L worksheet. And the way if you want to set this up, it's quite simple. You just basically go, what is it? Yeah, so under here, so link. So you click on link, you click on place in this document, and you can link it to a name that's used in the model, or you can link it to a worksheet. So for example, let's say you want to link it to a worksheet. Right, let's see. Okay, so I guess you could maybe just link it to scenarios. No, to let's say summary over here. Right. So if you right click on it and you go edit hyperlink, it's taking you to summary worksheet cell A1. So if you click on it, it takes you to it's wrong. But anyway, it's supposed to take you to cell A1. So it's a way of like jumping around different worksheets from the index sheet if you have a very large model, right? So that's one. Sorry, one sec. It was hung for some reason. This one's hung too. Okay, let's go back to that model again. So that's the hyperlink feature. Now, the other one is the check flags, right? So it's important. It's good to have check flags in your model. So then, as you run your model, you know whether the model is having any mistakes. So, for example, a good easy check flag is, for example, the balance sheet, right? So you always want to make sure that your balance sheet balances, right? So there's a bunch of balance sheet. So this is basically looking at the total equity minus the total net assets and making sure that it equals each other at the end of every period, right? And as you can see, it's and the way the formatting works, if you look at the formatting, is that if it's a positive number, it outputs a number. If it's a negative number, it outputs a number as well. But if it's a zero, so if the balance sheet balances, net assets minus equity should be zero, then it outputs a green colored OK. So that's how this works. The formatting is positive number, output this format, negative, output this format, and if it's a zero, output is zero, then output this format. So that's how that works. The check flags. Let's see what else. Yeah, so if you look at this is the today function. So it basically means every time you refresh the model by pressing F9 to calculate, it always puts in today's date. The print model macro button. So if you look at the index worksheet, to print main model sheets. So with one click of a button, because there are multiple worksheets in here, you want to know which worksheets you can pick and choose which worksheets you want to print, right? So so if you look at the coding, it basically lays out all the names of the worksheets that you want to print out. So that's the print macro button. Let's look at the assumptions sheet. The assumptions book is a it basically lays out all of the assumptions in the financial model, but it does it in a book format. What do I mean by that? So basically, it's laid out nicely like a book. So all the assumptions are laid out in here. And oftentimes, as the modeler, you want to make sure that someone else signs off on all of the assumptions in the model. So that's what this assumption book is set up for. And you see that at the bottom, there's a sign-off sheet. So whoever is the people that need to sign off, they can sign it at the bottom of every page. And how is this all set up? So if you look at Control P and then you go page setup. So on the page setup, there's a bunch of stuff you can do. You can adjust the print size, right? You can also make it fit to, let's say, 1 page wide, or you can make it 1 page tall, sort of thing. So you can size the printing to the dimensions you want. You can make it portrait versus landscape. Under headers, so if you go custom header, right? So by putting so there are actually different buttons. So format text, insert page number, insert total number of pages, insert the date, time, file path, file name, sheet name, picture, and format picture, right? So there's all these different options. So if you put if you click on file over here, in the left-hand section here, you see the file name being outputted. On the right-hand side, if you click on worksheet, then it shows you the name of the worksheet on the top right hand of the printout. Custom footer. So you can actually if you include the file name, the path name, and the file name, so then it prints out the path file here. If you put the date and time, then it prints out the date and time here. You can also insert a picture, right? So if you insert a picture, let's go. Yeah, so if you select the picture, yeah, so I basically pasted the picture again twice. But yeah, you can put the company logo that you work for as a branding exercise at the bottom of the worksheet, for example. Right, so you can actually insert pictures for the sign-off box as well as the company logo for branding purposes. Oh, okay. So the other one as well is, let's say there's multiple worksheets, but you want to be able to jump to a certain worksheet with a shortcut key. You could actually set up a macro. So for example, I've set up a macro here called go to index, right? So all it is it says go to the index worksheet and select A1, right? And then I've basically made that so go to index. Where is it? View macros. It's over here. So if I go to index and I go options, I can actually give it a shortcut key. So I could make it, let's say control. Yeah, let's make it control I, right? So if I go control I, link it to a shortcut key. So let's say I'm all the way at the end here. If I press control I, it takes me to the index worksheet. So if there's a really important worksheet that you always need to take a look at, rather than using control page up to try and find that worksheet and that spot, you can just use the macro and link it to a shortcut key to be able to access it anytime you want. That's going to save you time. Okay, let's see what else. Yeah, so social uses, cash flow waterfall, we already talked about that. So the summary worksheet. So your model should always have a summary worksheet. It's like a dashboard right? So all of the key outputs from the model should be in this worksheet. So we've got the same cash flow waterfall worksheet here as well. So all the key outputs should be here. So it means that you don't have to go through each calculation worksheet to try and hunt down the information that you're trying to get. It should all be nicely centralized in this dashboard, right? And it's got the same sources and users table too. And then the other one as well is if you go Alt V for view and P for print, you can actually see what you're printing out. So for example, if you only want to print this and take out all of this, you can do that by going set print area like this, right? So then you only print out this section here. Or alternatively, and then you can also manipulate it. Let's say if you want to print all this stuff down here. So you can manually set how you want to print. And then you can also set where page 1 ends and where page 2 starts. So you can also manipulate this and make this bigger and so forth like that as well. So that's the print area setup. So it's Alt V for view, P for print. And then once you're done with setting your print area, you can go Alt V for view and then N for normal, and brings you back to the original setup. Okay, so that's the the Greenfield model. I don't think we'll go through the other stuff, so let me just get out of that. Let's have a chat about Project Black. Project Black is an M&A model. This is a model. This was a model when I was advising a client on buying one of the Singapore generation companies that Temasek was privatizing. This was back in 2008. So one of the key things about this is that the Singapore market. So in Taiwan, when the private sector owns power plants, it's all done with bilateral contracts with TPC. So TPC pays them for the energy produced. But in Singapore, it's a merchant market. What exactly is a merchant market? It means that every power plant in the country competes with each other to sell electricity. So the way that works is that every half an hour, every power plant in Singapore puts in a price at which they're willing to sell power at. So this is known as a dispatch curve, right? So you have the cheapest power plants to the left and the most expensive power plants to the right. And if everybody behaves rationally, they bid a price which is their short run marginal cost, which is basically the variable cost plus their fuel cost. And the way it works is so this is the dispatch curve, and let's say so this is the amount of energy that the power plant can produce on the x-axis. The y-axis is the price that they bid at, right? So let's say at the half-hour mark, the demand is over here. If the electricity demand is here, it means that this is the plant, this coal plant is the marginal plant, and this plant is the one that sets the electricity price for that half an hour. So during the half an hour, everybody sells electricity at this price, which means that everybody to the left of it makes a profit. Everybody to the right of it is shut down. They don't produce any electricity because they're not able to sell at that price. So over the course of a day, as power prices peak and ebbs, then the prices go up and down accordingly. Likewise, if some of these power plants are down with outages, then everybody moves to the left. So then power prices become more expensive, right? So this is how the Singapore market works. The problem with the Singapore market right now, and actually with most countries, is because of inflation in the last year or two, oil prices have gone up to crazy high prices. And in Singapore right now, most of the power plants are gas-fired power plants. And the gas prices that they pay, it's linked to oil price. So if the higher the oil price, higher the gas price, and therefore higher the power prices in Singapore. So everybody's getting killed on power prices right now in Singapore. And which is why the government is so keen on building solar projects in Singapore, or build it in Indonesia and Malaysia and importing that energy into Singapore to be able to hedge out this gas price risk, because obviously solar projects do not need gas to produce electricity. So that's why there's a lot of interest there now to do this. And you would think that, and the other thing to note as well is if you look at the cash flow worksheet, the summary worksheet, this is the cash flow for a gas-fired power plant, essentially, right? This is how much money they're making, the envelope. Guess where most of their cost is going? Fuel costs. So more than 90% of the revenue they receive is paid out to the gas supplier. So their margins are actually very, very thin. So even with gas prices being super high, power plants aren't actually making much money. And that's kind of like the problem we're facing in Singapore right now. And with consumers getting squeezed and industrial customers, there's a strong interest in building solar. And that's a trend that's kind of we're seeing everywhere, not just in Singapore, but there's a strong economic incentive to build solar power projects as well as offshore wind and onshore wind because of renewables in general, because commodity prices are just going through the roof at the moment. So that was kind of like the final thing that I wanted to discuss.